Welcome to this lesson. I'm Ambassador Osbert, a teacher of chemistry in our group, the BAC Science Education Consultants. We're here saying that learning must continue from wherever you are. Regardless of any challenges you're meeting, please let learning continue taking place. We are back to our chemistry lesson about electrolysis or effect of electricity on substances. And today we are going to look at ionic theory of electrolysis. Ionic theory of electrolysis. I want to remind you of the meaning of the word ion. Ion is more related, it is related to the term atom. In a way that this is always charged, but this is always neutral. In lower classes, you must have learned about the difference between the two. So today we are going to look at how ions can be used to explain why electrolysis takes place. Remember, in our previous lesson, we defined electrolysis as the decomposition of a substance which must be in either molten form or solution form. And it happens when current has passed through this substance. The substance actually was called an electrolyte. So today we are going to study why electrolytes conduct electricity and why do they decompose when they have finished conducting electricity. So this was a theory put forward to explain electrolysis from the ionic view of it. So we are going to put down that ionic theory was put forward So we have the theory believing that an electrolyte contains electrically charged particles which are called ions. And these ions can either be positively charged or negatively charged. Yes, most of the times the positively charged ions from the lower chemistry, the positively charged ions are always obtained when an atom loses electrons. And for an atom to lose electrons, then the number of electrons in the outermost energy level should be either 1 or 2 or 3. And when we have that type of electronic configuration, those are always metals. So when we talk about cations or positively charged ions, those ones are always metal ions. You can name some good number of metal atoms, e.g. you can talk of zinc, which loses 2 electrons and so becomes zinc 2+. You can talk of Na+, and many others. We have ammonium ions, also they are positively charged, and hydrogen ions. The negatively charged ions are called anions, and these are always obtained when an atom when an atom gains electrons. For an atom to gain electrons, then the number of electrons in the outermost energy level should be greater than 4. Those are always nonmetals. And so, all nonmetals actually form anions when they are charged. During electrolysis, this is what happens. You have an electrolyte which is having positively charged and negatively charged ions. During electrolysis, positively charged electrode. Remember, in our previous lesson, we talked about electrodes. And electrodes can be negatively charged also, or positively charged, depending on the terminal to which this electrode is connected. We say if this terminal is connected to the positive end of the battery, if it is connected to the positive end of the battery, then it will be positively charged, and so it will be the anode. If it is connected to the negative end of the battery, then it will be negatively charged and will be the cathode. During electrolysis, like charges repel and unlike charges attract. You have positively charged ions, the cations. For them, they will be attracted to the negatively charged electrode, which is the cathode. And then the anions, which are negatively charged, will be attracted to the positively charged electrode, which is the anode. When this happens, it does not stop from there. The science continues that when these are attracted, when the cations, ions in solution or molten form will gain an electron and hence an atom, a neutral atom will be produced. So atoms are produced. So when this cation reaches the cathode, remember the cathode is negatively charged, an indicator that it has more of the concentration of electrons. The electrons are more concentrated there. Remember, electrons are negatively charged. And so, the sodium, which is positively charged, will attract an electron and it will end up becoming a sodium atom. Remember, when sodium atoms combine together, they will end up forming sodium, which is a metal. Likewise, when anions reach the anode, they are also discharged. And in this case, since here they were discharged by gaining electrons, remember the anode, it is positively charged and indicates that there are no electrons. Instead, there is a deficiency of electrons. So the anion will be discharged by losing electrons to form atoms. But these atoms are unstable. They can combine, which combine to form molecules. E.g., if you consider an anion, for example, an anion, for example, a chloride. An anion, chloride, which is in the electrolyte, an electrolyte that is in solution form. When it reaches the anode, it will get discharged by losing the electron to form the chlorine atom. Chlorine atom, which remains in gaseous form. This equation is preferably presented as this. The electron can move from here and it goes the other side. In mathematics, we can say that when an integer or any value jumps equal signs or jumps any inequality sign, it will always change the sign. We can take this to be an equal sign, that when it jumps to the other end, becomes positively charged. You cannot find this chlorine atom alone. The chlorine atoms will end up combining together to form one chlorine molecule, and this is the one which will be given out. You can see that what was, for example, sodium chloride. You can realize that if we had this electrolyte as sodium chloride, at the end of electrolysis, you have formed sodium metal alone and you have formed chlorine alone, an indicator that during electrolysis, there is always decomposition. There is always formation of a new substance. What was sodium chloride has formed two separate substances, chlorine gas and sodium metal. You will even see gas bubbles coming out, a greenish yellow gas. You will see possibly a coating, a gray coating at the cathode. Can we maybe simplify this in a diagram? Can we briefly simplify this in a diagram? So, this is our battery connected to this end and then the other end connected to this terminal. We have removed the bulb because we are sure if this is an electrolyte, definitely the bulb must produce light because an electrolyte will conduct electricity. According to our explanation here, this electrolyte is actually sodium chloride. Sodium chloride solution. You can call it NaCl. So, this is our battery and it is showing that you have the negative end, this side, an indicator. Sorry, this is the positive end, an indicator that this will be a positive terminal. You can call it the anode. You can call it the anode. The other end is connected to the negative terminal of the battery. So this is negatively charged, and therefore this is called the cathode. This is called the cathode. This electrolyte, according to ionic theory of electrolysis, it contains ions. Some of them are positively charged, some of them are negatively charged. Can we look at our electrolyte? We have an electrolyte sodium chloride, NaCl, and we say that when this is in solution form, it is an indicator that sodium ion is independent of the chloride ion. They can appear independent of each other. In this solution, they are just scattered. They are just scattered anywhere. But the moment you connect the terminals to this electrolyte, you are trying to orient these ions to different directions. They will move. You have here sodium and chloride ions. What will happen? According to ionic theory of electrolysis, the cation, what is the cation in this case? The positively charged ion, sodium, will be attracted to the cathode. So we shall have sodium ions parading around here. The sodium ions will be parading around there. The sodium ions, I'm representing them with a positive charge. And then the negative ions, the anions, are attracted to the positively charged ions. So you shall have the negatives attracted. The negatives will parade around the anode. So we are saying that when the negatively charged ions are attracted to the anode and the positively charged ions are attracted to the cathode, there is always another process called the discharge. The discharge happens in a way that the positively charged ions, the cations, will gain electrons. And they will form atoms. So you will end up seeing a coating of sodium, a gray coating here, a gray coating there, a gray coating here. So this one will attract sodium, in other words, attract sodium ions. And then you will end up seeing bubbles around this electrode. Bubbles, some small balls containing chlorine gas. So this one will attract chloride ions. When the process has ended up taking place, the whole process, the decomposition, the changing of sodium chloride into sodium metal and chlorine gas is the process of electrolysis. For now, I'm happy that you have followed and you have understood. We shall meet this several times throughout our topic. Continue protecting yourself. Make sure you remain safe. Continue learning. Nice time.